This video covers Chapter 23, Comparing Two Proportions. So in Chapter 23, we're going to cover two sample problems using proportions, the sampling distribution of a difference between proportions, large sample confidence intervals for comparing proportions, and significant tests for comparing proportions, as well as the +4 confidence interval for comparing proportions. We did this on a single proportion in Chapter 22, but it's a little bit different when we're comparing proportions. So let's take a look at some two sample problems. So two sample problems of proportions. So suppose we want to compare the proportion of individuals with a certain characteristic in population 1 and population 2. Let's call these parameters of interest P1 and P2. Very creative, I know. The ideal strategy would be to take a separate random sample from each population and compare the sample proportions with that characteristic, okay? So what if we want to compare the effectiveness of a treatment and another treatment, so treatment 1 and treatment 2, in a completely randomized experiment? So this time, the parameters P1 and P2 that we want to compare are the true proportion of successful outcomes for each treatment, right? And we use the proportion of successes in the two treatment groups to make the comparison. So let's look at our notation. So I've got population 1. Here's the true population proportion, its sample size, and the sample proportion for treatment group 1. And here we have the same for treatment group 2. So what we would need to do is choose a simple random sample of size N1 from population 1 with proportion of successes P1 and an independent simple random sample of size N2 from population 2 with a proportion of successes P2. When the samples are large, the distribution of P1, P hat sub 1 minus P hat sub 2 should be approximately normal. The mean of the sampling distribution is going to be P1 minus P2. That is, the difference between the sample proportions is an unbiased estimator and the difference between population proportions. And the standard deviation of the distribution will be given as follows. P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N1. So see, it's kind of double the formula we were using before. So let's take a look at a visualization. So here we have our sampling distribution of P1 minus P2, all the values of P1 hat 1 minus P hat 2. We have our true mean, P1 minus T2, and our standard deviation is given by this formula. You will be given these formulas on exams, at least in my class.